I'm going to talk about so a little bit of plumbing that I did in order, or Claude and very tall man who works for Swiss API. That one right there did to make it so that you could run Sparkle queries over FHIR endpoints. I thought I was going to talk about who we are, but we did this for let's see, DBCLS at Biohackathon in Japan because we wanted an excuse to go to Japan, which is why we do everything. That's why we're here as well. Problem statement, yeah, so what we're going to talk about, I'm going to talk about problem statement, motivation, what our goals are, how we did it, future work and futurist work. The slides are, there's a tiny URL in the middle of those slides links that will take you to these slides. You can also go to the source and change the slides as I'm presenting and see if I read along. So either be nice or be entertaining. It's a problem statement. We got a lot of data out there in clinical data in a form that you and I are not used to using. We're used to using open public data, and clinical data is the absolute polar opposite of that. But there's an RDF representation of FHIR. FHIR is very exciting because people are excited about it, and that makes it popular, and that's all we really need to care about. There's an RDF representation of it. In principle, all that data is out there. It's just this huge map. It's this huge graph that we could query, we could join the data against. And why would you want to do that? For research or for clinical decision support, personalized medicine, that kind of thing. Now, well, you could just sit there and say, ask for every resource and dump them all into a big database. And at that point, you have this huge materialized graph that's immediately out of sync and takes a lot of memory, and there's not much point to that. So whenever I can, I like to do query transformation and make everything virtual. So we have a motivating use case in particular. Let's see, is there anything to add here that I haven't already talked about? Yeah, if you want to, actually, Claude, if you want to stand up and next to me and cover things that I failed to mention, that would probably be helpful. Do you want to add anything from this slide?
So not so much to add beyond what Eric has mentioned, but really the idea is that EHRs, electronic health record systems, don't really tend to expose their data as RDF. Their endpoints tend to be more JSON. So what we wanted to be able to support is the ability to write Sparkle queries and then translate those so that they can hit these native endpoints and then get the data back. And this would allow us to get FHIR RDF data that we can then link to information elsewhere, potentially, for purposes such as pharmacogenomic and so on.
And Yervin, if you want to add stuff too. Oh, hey, I remembered your name. Can happen from time to time. So clinical decision support is typically a bunch of clinical factoids about the patient, like whether the state of their genomics or something like that, their metabolism, whatever, how many organs they've got and where they are. There's clinical knowledge bases are typically going to hold information about if this particular SNP reduces the metabolism for some particular medication, and therefore you have to reduce the medication. And then there are clinical guidelines that are generally expressed as these things called clinical decision support rules, which say if you see X, then you'd think it would be if you see X, then do this, inject this life-saving drug into the person. But really, it's just either pester the physician or maybe make a medication request that the physician gets to approve or something like that. So CDS rules don't save lives. They remind physicians to save lives. Takes some of the pressure off us, honestly. So we've got an example. Here, why don't you do this one?
Okay, so this is an example actually that we're working on. So a patient is immunosuppressed and they're on the thiopurine. So typically, or maybe not so typically, but technically they should undergo genetic testing to make sure that they are a normal metabolizer of the drug, because if they're not, if they have a potentially non-functional allele or two, it could be very harmful to the patient. So then the dosage of the medication has to be reduced in this case. And so this is a case where we would like to potentially mix FHIR data with information from a knowledge base, from a genomic knowledge base, that could give us an intermediary fact that says that the patient is heterozygous for the non-functional allele, and therefore the dosage has to be reduced so much. And so this is a case where we'd like to link potentially the FHIR data and not hard code this information in a rule.
So this is sort of an ideal case where you've got a knowledge base that I talked about in the second bullet point here. Then we consult the knowledge base in the queries. In reality, the stuff, the vetting process by which CDS rules become approved is that people look at the knowledge, clinical knowledge, and write specific hard-coded CDS rules. So in fact, we don't end up doing the join against the second thing yet, but we'd like to get there, and I'll talk about that in the futuristic work at the end, or he will actually. So that means our case is pretty simple. We just say, okay, I want to query some Sparkle. I want to write a Sparkle query that connects a few resources across n different patients, all the patients actually, because we want to find out all the ones that we need to do something about. And we need to query some observations and some procedures and some patients. And there's this, so yeah, that's the use case, that's our motivation. But it's also just geeky fun, so we just like to do things like this. And also CDS tools can save lives, which is less cool, but still fun. What we're trying to do here, say we got this common problem, we've got a little technical solution to it. We've got this, this is a problem that a lot of people are going to face, and so we'd like it so that when somebody else runs into the same problem, the sort of recognition of patterns and has to transform them into some REST API and stuff like that, that they say, oh, this tool exists out there. I can either steal the idea or even maybe use some of the code. And the idea is hopefully making it simple will make it easier to actually use it than to go and roll your own. So the data structures we're working with, we've got a Sparkle query, which is a collection of joins, unions, optionals, and minuses over bags of triples. The bags of triples are basic graph patterns, and then there's just various operations you can do, like joins and optional, et cetera. So there's algebraic operations you can perform on them. I'm using what's the name of that? Using a set notation here just to look smart, but it's not really necessary. So another data structure we're working with is the FHIR REST API, which you can think of a map from a particular resource, say observation, to a bunch of query parameters you can say. I want to get /observation / or observations / code equals blah, 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 and it'll give you back all the observations that have that code. And then we've also got a FHIR schema, which is a map from a resource name to lists of properties that appear in a particular resource. Recognize all components in query. So the goal then is to take this query up here, recognize all the places that we can represent that query by FHIR REST API calls, execute the query, get the data back, re-execute the query, because there's some stuff that we weren't able to express as REST API calls. Like I want to make sure that the level is above a certain amount or something like that. Anything complex, the REST API isn't going to support, so we have to re-execute the query in order to actually enforce all the semantics that were in the original user's query. And then we also have to, at that same time, we're also binding all the variables, which will allow us to make queries over the next observations that are implicit in this series of resource requests. So let's see, where am I? So example of the REST API is that I've got let's see, where was it? oh, I have to do this. I have to go down. This is one of the things. If you're trying HackMD slides, which are pretty cool, but they're kind of different and new. And like when you get here, you get to say, I want to go down, and then you dive into new things. It's a new topology. An example would be, I've got resource name for patient and properties code. So like I went question, some HTTP : blah, 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 /patient, !, code equals HTTP : blah, 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 /3141-9. It's actually not the right example because it's not going to show up in a patient. It's going to show up in an observation, but it's an example. Get the idea. And then that is going to correspond to a Sparkle graph pattern. It's going to correspond to an RDF graph, which is in turn you can query with the Sparkle graph pattern, which splits that system encode up across two different properties. The system encode that were separated by a pipe splits them up, and then has this miserable RDF rest RDF first to be able to match any element in the list, et cetera. And so when you get a Sparkle query that looks like this, you want to turn it into a REST query, a REST API parameter that looks like that. And you might have 5 different REST API parameters that get stacked together before you do the query. So now it becomes just a question of programming. Honestly, it always was, because the definition of the right answer already came from the existence of the spec for FHIR RDF. We just need to write the tools to make it happen. So let's see, we got the engine we used was, the Sparkle engine we used was Communica, which has some challenges I'll describe to you in a bit because it's meant for distributed use and it wasn't really meant for this particular use case. FHIR REST API, yeah, we already know about that. FHIR schema, and we grabbed I think we wrote the FHIR schema down as the method we expressed. We used checks to express it because it was easiest to traverse the checks J. So the goal is to basically produce a bunch of FHIR REST APIs, get the data back, and query it. So that turns into a recognition problem. I've got a query that's got a bunch of stuff, and I got pieces of it that a human could look at and say, oh, I need to take this and turn that into this and this and turn that into that. And we need to make the computer be as smart as a human. And so the way we approached it was we created these things called ArcTrees, which is to say, I've got here it is expressed in TypeScript, but it's basically, just picture a graph. I mean, it's rather a tree that has labeled nodes. And the labeled nodes capture the triple constraints that were corresponding to that part of the graph. And this is reflecting the reality that we're basically mostly working in arcs out data. Like in principle, everything, the RDF graph could be symmetrical, but in reality, we tend to think of things as arcs out. So this is an example of one of these trees, or expressed in, I thought I had a picture of it, but I don't. Anyway, so sometimes you'll see 2 different elements in the 2 outs in a particular tree because there's like the example of the code and system. So, oh yeah, there's our picture. How about that? Let's see, connecting var data type. Oh yeah, so this in principle captures your entire RDF graph because you've got all the connections between some variable here and some, the fact that this here is the same as this here and here. But if I've got a graph, if I've got a variable like patient resource that I'm going to be looking at that's connected to something else in the query, I want to know about that just because it makes the thing efficient. So what I do is I break the query down into ArcTrees to capture the sort of the hierarchy of the Sparkle query, and connecting variables that show all the places there are variables that connect any of the ArcTrees. This means that there's no typing. This is just duck typing. So if I see RDF type is just another property. So it doesn't. The system is going to be much more efficient if you include types, like back in here when you include these types. The reason it's more efficient is because it greatly constrains the search space that it has to look for the particular properties when it's walking through the check schema and saying, does this property exist on this resource? Does this property exist on this resource? If it's only got one resource, then it's just a go, no go. If it's got a lot of resources, it's walking through and trimming the list. But it works fine anyway. So if you want to do something meta, like I want to look across all of my not my observations, but all of my FHIR resources and see which things are in a status of verkufte, you can do that by just writing the query, and it will automatically iterate across all the different property types. I mean, all the different resource types. What else? Multi-resource queries or joins. What was that about? Oh yeah. So this is, yeah. So then here I'm going to go and get a query, do a query on observations. And you can see my cursor? Yeah, my cursor's there. And then I'm going to get n results. And then with the bindings that came back from that, I'm going to do queries over these. And then I'm going to get n2 results. And then I'm going to go join that against patients. And so this is effectively a join operation. So as Yervin pointed out, so Eric, you're writing your third or fourth Sparkle implementation. And so it was, it's basically, it's doing the joins. You just have to make sure that you do the math right, and practically it's better to have everybody debug one than everybody write their own bugs. The other reason this shows up, this is interesting, is because when people are doing this stuff using, say, conventionally in Java, they'll write some code that will iterate, that will basically query for the observations. It's hard-coded Java that goes and writes these REST queries. And then they'll iterate across the results, and then they'll iterate across those results. And you basically have to do the math correctly. And so everybody writing that procedural code has to do it right. And so again, the notion of having a declarative representation of a whole choreography that's shared, that's got some shared debugging in it is useful. Future work performance is close to optimal for the recognition part. For the query part, when I get the data back and I have to do the Sparkle query, the package I'm using, Communica Query Sparkle, is meant for distributed use cases. And so it's really inefficient when querying lists. There's an issue on it. I meant to drop a link to it, but if you Google for that, you'll find it. Another way to handle this is migrate to Java, which would allow it to integrate with other tool chains, and we could use RDF for J or Jenna or something like that, and already be in a space that's much more efficient in that for the Sparkle queries. That's not going to be too hard because it's already in TypeScript, and I wrote a program a while ago to mechanically convert Java to TypeScript, and so I just have to write the program again in reverse. The Java to TypeScript was awesome because I called it Java Tots, and so I love the name of it. Have to prove completeness and achieve completeness. So the query is, joins of unions and knots and joins of, I've got arbitrary expressivity in the Sparkle query, and I have to make sure that I am honoring that in my algebra or in my code, just my procedural code. Recognize all the list elements. Right now, I just hard-coded the RDF REST */RDF first pattern to traverse lists. So if you write it some other way, or you assuming that's going to be the first element, it won't it won't recognize it, and so it won't it won't be efficient and add that particular query parameter to the FHIR request, and so you'll get more stuff than you wanted. And then I also have to make the test suite merciless, because right now it's got coverage, 100% coverage, but it isn't as mean as it needs to be. And now we turn to Claude for the futurist work.
Thank you, Eric. So one thing I just wanted to mention from what Eric presented is sometimes Sparkle is more expressive than the FHIR API. And so there's a two-step process. So the first is to take the Sparkle and align it with the FHIR API and then fetch the resources that the Sparkle specifies. And then after that, you can still apply the Sparkle on the results to do additional projections or filtering. And so this is it allows one to use the expressivity of Sparkle even if these EHRs or FHIR servers don't support that. So what we really want to be able to do is to be able to link FHIR RDF data with external knowledge bases. So currently, most medical knowledge is captured. So we go through clinical guidelines, and then we say, oh, okay, here's a part of the guideline that we would like to implement as a clinical decision support rule. And so we capture the information that we need, write our clinical decision support rule, and so on. But sometimes that knowledge is probably better captured in some kind of knowledge base. And so, for example, if you look at medications and contraindications, sometimes my only question is, does a patient have any contraindications for medication? And all I probably want to do is just give the patient's active problems in the problem list, and then the medications they're taking, and then have some knowledge base tell me, oh, okay, they be careful with these medications because they have a contraindication. And I don't want to code all of this in the rule. I mean, I'd be coding a lot of information in the rule, and pharmaceutical content providers can do this a lot better than I could. And so by delegating to these content producers who have really deep knowledge of the domain, I can leverage this so that my rule doesn't have to have all this information. Oh, this error, okay. So here's a very simple graph, because I'm trying to figure out graph viz. But you can see, so the idea typically, our CDS systems fetch data from the EHR. We can use something called CDS hooks, which is triggered by an event. It grabs patient data queries from the EHR, sends it to a CDS clinical decision support service, and then the clinical decision support service processes the patient information, additional information, and returns guidance, which can either, in our case, I'm putting it back into the EHR, but in reality, it could manifest itself in different ways. We could write back to a FHIR server, or we could trigger actions within the EHR. And so here, the idea is there might be a need for something that sits in between, so that when you fetch the data, before you give it to the CDS service, you actually pass the information of the patient to some knowledge base. So in this case, you could pass in the results of genetic testing. And then the knowledge base comes back and provides additional facts. And then these facts are added along with the rest of the patient data. And then the clinical decision support service can write rules that makes use of these facts. And so we'd like to be able to get there so that we can have knowledge bases that could be shared potentially, and then clinical decision support rules that would just make use of facts that would come out of these knowledge bases. And so do you want to talk about that use case? Yeah.
It just, if you talk over, I'll point to the completeness.
Okay.
First graph represents the Fhir-Sparql. The second graph represents the clinical KB that we'd be joining it against.
Yeah, so here you can see that the clinical KB returns a contraindication rule, and then it could say, it could filter by some specific characteristic of the patient, maybe the fact that they're heterozygous for some non-functional gene. And they could propose an action, a dose reduction action. And how you split it really varies. I mean, you may want your knowledge base to simply take the patient's genetic information and give you some facts like, oh, is there an intermediate metabolizer of this drug? And that's it. And you may not want to make those recommendations because you want to leave that to the clinical decision support system to do, because it may be localized based on patient formularies and or organizations' formularies and so on, or the medications that are preferred by a given organization. Or you could say, well, you know, I have this knowledge, this genomic knowledge, and I also have this drug knowledge. And so the knowledge base could give you all of that information and then let the CDS system pick what it wants to use, for instance. So there's a nice set of possibilities there. And it's an area that we're starting to explore.
Pursuant to that, come play with us. And, well, okay, this is an ancient picture, but I was told that I look like I have Mark Zuckerberg hair, so if anybody wants to rescue me with a pair of scissors, please. Questions, whatever, they don't even have to be entertaining. This is the cost of doing your slides as a slave to a Twitch live stream.
Thank you very much for the very interesting talk. Do you have any experience with deploying or trying to execute Sparkle queries from, let's say, an academic hospital information system?
Rick, do you want to speak to the FHIR SAS use case that we use it for? If Rick is here. Ah. Three of the microphone. Huh. Well, you can shout it to me and I'll shout it to them.
We did use it at the UMCU test in LUMC to try out the first prototype. We haven't used it in practice yet. Did you hear it?
Oh yeah, you got that? Kept through? Okay, cool.